Let's take a trip down memory lane. Remember that monolith e-commerce application you work on? The one where the marketing team decided to change the font size in the newsletter footer, deployed it on Friday afternoon, and somehow crashed the entire inventory management system? Good times. We laughed, we cried, we spent the weekend restoring the database. The problem, of course, was that everything was hopelessly tangled together. Service A called Service B, which called Service C, and they all had to succeed perfectly in order within 500 milliseconds, or the whole house of cards collapsed. We promised ourselves we'd fix it when we moved to microservices. And what did we do? We built a distributed monolith. We just replaced in-memory functions calls with HTTP requests and congratulated ourselves of being cloud native. Today, we're starting a new series of Microservices Architecture Patterns, and we are tackling the root of the evil, tight temporal coupling. We're talking about event-driven architecture, especially using Spring Boot and AWS EventBridge. We're going to learn how to let the services scream into the void and hope someone is listening rather than micromanaging every interaction. My name is Sergio, and I spend way too much time thinking about distributed systems architecture so you don't have to make the same mistakes I did 10 years ago. This video is the first entry in a complete playlist, Microservices Architecture Patterns. Over the next few videos, we're going to look at sagas, Resilient 4G, CQRS, and more. Basically, a survival guide for the modern developer. If you're tired of PagerDuty alerts ringing at 3 AM because a service you never heard of timed out, hit subscribe and like the video. Let's build something that doesn't completely fall apart when the network sneezes. Why do we resist event-driven architecture? It sounds great on paper, decoupling, scalability. We resist it because, as developers, we are control freaks. We love synchronous REST APIs. They feel safe. It's a phone call. I call you, you answer, you give me the data, instant gratification. If you don't answer, I panic. I retry 3 times immediately. I flood your service with requests until you completely fall over. That is the reality of synchronous communication in distributed systems. It creates a fragile chain of dependencies where the slowest service dictates the performance of the entire system. We tell ourselves, this REST call is simple, it's fine until you have 10 services chained together, and your latency graph looks like a mountain range. EDA forces us to let go. It forces us to accept that the world is asynchronous. You send a message, and I trust that it will be handled. Eventually, the uncomfortable truth is that asynchronous communication is harder to design, harder to debug, but essential for resilience. Today, we are covering 5 crucial pillars of building a real-world, event-driven system. You will hear these 2 terms thrown around constantly. Let's simplify them with an analogy that doesn't involve actual dancing because nobody wants to see that. Orchestration is like a micromanager bus. You have a central order service. When an order comes in, the service calls the payment service and waits. Then it calls the inventory service and waits. Then it calls the shipping service. If the shipping service is down, the order service has to decide what to do. It holds all the logic. It knows everything about everyone. It works because we have created a God service. If that orchestrator goes down, nobody knows what to do. Choreography is what we are aiming for today. In choreography, there is no bus. The order service simply pushes an event, order placed. It doesn't care who is listening. The payment service hears order placed and processes the payment. The inventory service hears order placed and reserves stock. These services don't even know the order exists. They just react to events in the environment. Choreography minimizes coupling because producers don't need to know about consumers. Services can evolve independently. If tomorrow the marketing team wants to listen to order placed events to send a thank you email, they just subscribe. The order service doesn't need to change a single line of code. That's a dream. To make choreography work, you need a reliable nervous system to carry these signals. In the AWS ecosystem, that's EventBridge. Think of EventBridge as a highly available serverless mailroom in the cloud. It has 3 main components. Event buses. This is the hallway where everyone shouts their events. You usually have a custom bus for your domain events. Rules. These are the mailroom clerks. They look at all the events passing through the bus and decide where they need to go based on patterns. You filter by source, detail type, or specific data inside the JSON payload. And targets. These are the destinations, an SQS queue, a Lambda function, another event bus, or an API gateway endpoint. The beauty of EventBridge is how it enforces decoupling. Your Spring Boot application acts as a producer. It uses the AWS SDK to put events onto the bus. The producer's job is done the moment EventBridge accepts the event. It doesn't care if the consumer is down, slow, or on fire. This is true decoupling. Here's where EDA goes wrong in the real world. It's 4 p.m. on a Friday. You decide to change the user ID field in your event from a string to a long because it's cleaner. You deploy the producer. Instantly, 5 downstream services owned by the 3 different teams start crashing with deserialization errors. Congratulations, you just broke production via asynchronous sabotage. In REST, you have OpenAPI, Swagger, specs. They are rigid. In EDA, your events are your API. They are a contract. You cannot just break them. You must treat event structures with the same discipline as public APIs. AWS offers the EventBridge Schema Registry to help manage this. It automatically discovers event schemas and allows you to download code binding for them. More importantly, you need a strategy for versioning. Never make breaking changes to an existing event type. If you need to fundamentally change the structure, introduce a new version identifier. Consumers must be built to be tolerant readers. They should ignore fields they don't recognize and handle missing optional fields gracefully, rather than throwing exceptions the moment a new field appears that they weren't expecting. If you take nothing else away from this video, remember this: in a distributed system, exactly once delivery is basically a myth. Event systems like EventBridge and SQS guarantee at least once delivery. That sounds nice and reliable, doesn't it? What it actually means is, we definitely deliver this event to you. We might deliver it once, we might deliver it twice. If a network partition happens during an acknowledgement, we might deliver it 5 times in rapid succession. Good luck. If your consumer handles an order placed event by charging a credit card and you receive that event twice, you just double charged your customer. They will not be happy. Your consumers must be idempotent. Idempotency means that handling the same event multiple times has the same net effect as handling it once. How do we do this in Spring Boot? The most robust way is usually tracking process event IDs in your database in the same transaction as your business logic. If you don't have this check, your system is not production ready. The biggest downside of EDA is debugging. In a monolith, you look at one stack trace. In synchronous microservices, you follow the HTTP headers. In EDA, an event gets published, disappears into EventBridge, gets routed to an SQS queue, picked up by a Lambda, which fails silently. Where did it go? It's a ghost. You cannot operate an event-driven system without a distributed tracing. AWS X-Ray is the native tool here. When your producer publishes an event to EventBridge, AWS automatically attaches a trace ID. The crucial part is ensuring that trace ID propagates all the way to your customer. If your Spring Boot app is consuming from SQS, you need to ensure the X-Ray SDK or the OpenTelemetry agent is correctly instrumented to pull that trace header out of the SQS message attributes and continue the trace. Without this, you will have 10 fragment traces instead of one complete picture of the transaction workflow. If you can't trace a request across asynchronous boundaries, you don't have a system. You have a collection of mysterious black boxes. So, why do smart developers build bad event-driven systems? It usually comes down to the cargo cult programming. We read a blog post about how Netflix does it, and we copied the tools without understanding the constraints. We use Kafka when we only have 5 events an hour. We use EventBridge, but then we make the consumers immediately call back the producer synchronously to confirm receipt, completely defeating the purpose of decoupling. We try to force our synchronous tools to behave synchronously because we are uncomfortable with uncertain. Get comfortable with it, the network is unreliable. Embrace the chaos. I can already hear the comments section typing furiously. Well, actually, Sergio, why use EventBridge? Apache Kafka is much more powerful for high-throughput streaming and replay capabilities. Yes, Chad, I know Kafka exists. Kafka is amazing. Kafka is also a Ferrari engine that requires a dedicated team of specialized mechanics to keep running. If you are processing petabytes of clickstream data, use Kafka. If you are building a standard business microservices that need to let other services know an order was placed, EventBridge is serverless, fully managed, cheaper at low volume, and infinitely easier to set up. Don't over-engineer your architecture just to pad your resume. To wrap this up, if you are moving to event-driven architecture, prefer Choreography. Let services react to facts, don't build a central dictator service. Use EventBridge for decoupling. The producer should not know who the targets are. Treat schemas as contracts. Don't break downstream consumers with careless changes. Use versioning. Make consumers idempotent. The network will send you duplicates. Handle it. Implement distributed tracing. If you can't see the flow, you can't fix it. In the next video, we are going to look at what happens when a business process does need coordination across multiple steps and rollback capabilities. We will be diving deep into the saga pattern. Now go delete some synchronous HTTP calls and replace them with events. And for the love of code, write idempotency checks. And see you in the next video. Bye!